Hi, everybody. Welcome. Episode 9 for Azure Cosmos DB Live TV. I'm Mark Brown. Welcome back this week. This week, I've got with me a special guest, Daniel Weber. Daniel, you want to introduce yourself?
Hi, Mark. Thanks for having me.
Yeah.
Yeah, I'm Daniel. I'm from Germany. I've been working with .NET, I guess, since 2002. That is,
Wow.
since the very first version. I've been doing it ever since. I've got a master's degree in computer science, and I've been developing this object graph mapper that we're about to talk.
Yeah, so you're going to show off this tool that I think a lot of people in the Gremlin community, at least those that are familiar with .NET and Gremlin, are familiar with. This is ExRam.Gremlinq, correct?
Right. Yeah, I guess it's kind of a niche. It's for .NET and for which it's not to say that this is the niche, but Gremlin and graph database in general kind of are is in the niche, so to speak. But I'm about or me and the community. I think the aim is to change that with the right tooling, and yeah, this is what Gremlinq is for.
Yeah, so tell me about it. What kind of what was the genesis, I guess, for why you created Gremlinq?
All right, so in the company that I work in, we at some point we decided to do a whole do-over of everything we got. So we got a pretty well-running product that runs on SQL and other techniques that are kind of outdated, you might say. And we decided, so let's do this over, right? Let's do this right this time. And we started out again on SQL, and we kind of figured that we have a lot of structure, our data. We don't have so much data in a sense of data volume. We don't fill terabytes of data, but it's heavily structured. So when we found out about graph databases, and we were already late to the party when we found out, I think it was 2016 or so, and graph databases have been around for quite some time at this point. We figured this is what we should be going for. This covers everything we need, right? All the structure. We can do queries on the database that wouldn't be feasible in pure SQL. We can do recursion, which again isn't really feasible in pure SQL, at least if you.
Well, it is, but it's just takes
if you don't like store procedures and all that stuff.
Some of the probably some ugly or challenging code. Yeah.
Yeah, we already had quite a good code base for entity framework. So we had all these entities, those POCOs, those plain old C objects, and we didn't want to give that up. We didn't want to give up the logic behind that. So we figured, so there's Gremlin, and the language is powerful enough for our needs. But is there something like entity framework which will do all the mapping, or is it something like Hibernate or something? And there wasn't. So yeah, challenge accepted, I would say.
So that's how this came to be then, basically. I see. So you had your existing application and services, and you realized that Gremlin, or just Graph in general, was a better database for what you were trying to do. And how do I get from A to B without having to completely refactor everything? It sounds like at the data layer there. Yeah. So that's interesting. So, well, need is always a good driver of innovation, and that's a great story for how this came to be. So I guess you want to just show off, I guess, and let us see what you can do with Gremlinq.
I can. So I will, for the sake of this presentation, assume some familiarity with graph databases and Gremlin. I don't. I guess I don't need to convince anybody to use Gremlin or graph databases in general. So we'll just start from here.
Well, let me ask you this, because I mean, some people may not be familiar with graph databases, or maybe just curious, but can you describe kind of at a very general level what a graph database is and why someone may use it?
Yeah, a graph database is from a conceptual view. So in contrast to the traditional view on data, which has for quite some time been row-based or table-based, like, right, where you would have your data organized in rows which could reference each other. The view on data as a graph is, you could say you could always model a graph in SQL, right? If you have your rows and those rows are kind of referencing each other. So this is where your nodes are, your vertices, and the edges are the foreign key references. And so, but a graph database would much more focus on the graph aspect, like would make it really a first citizen, like put the graph and the relationship between vertices right in the center. And it would not deal with rows and foreign keys and all that, but it would allow you to specify a set of vertices to go from, and where to go from there, and what to do there, and where to filter, and where to branch. So it's just a concept. Essentially it's got nothing to do with storage, because you don't store rows, and you don't store tables, and you don't store a graph. So on the lower levels, it might still be everything, especially for a graph database. It might still be everything. Cosmos DB does that with document storage, which lends itself very nicely to the graph view. It fits in quite nicely. Really, everything gets together. But it's not limited to that. You can. I think there's also approaches where you could store a graph on a traditional SQL database, or there might be other approaches. Other NoSQL databases like Cassandra are feasible for that too. So the graph concept it's just that, a concept. The graph database would let you query with its data through a language, either Gremlin or Neo4j uses Cypher, or there's other proprietary stuff. But they all got in common that the language has the graph baked into it as well. So the language reflects the view, and the concept in general reflects the view of the graph.
Yep. So I agree with what you're saying there. That's, or my understanding as well with that is where you see more emphasis on the relationships on the data. You know, and some of the workloads I've seen it used made a lot of sense. And in the past, you would have seen these built with relational databases. But something like a supply chain application is an interesting use case for like a graph, because you can actually follow parts that make up the bill of materials for a product all the way through that supply chain by writing graph queries and basically traversing that graph. So if you have a product or a part that's part of a lot and there's a defect in that, you can then write a graph query to say how many end products did that part go into, and then be able to send out, say, a recall notification to all those customers who registered their product that has that part that came from that lot. Other use cases that I've seen graphs used as well is device manufacturers that manage like firmware updates. Like they'll have like consumer electronics, and some of them, you know, as it is the case with consumer electronics, not everybody updates their devices, if you will, on the same schedule. In some cases, there's a dependency between versions of firmware updates that have to be followed to know which version they need to upgrade to next, depending on which version they're currently on. and which of those are, say, critical path versus optional, that sort of thing. So I've seen graphs used in that scenario as well, because there's a very strong, because what was most important is the relationship between the different firmware versions and the devices themselves, and then also the path that a device would have to take to update update its own firmware. So anyway, there's lots of interesting use cases for it, and I think it's a fascinating space. Yeah.
Definitely, yeah. You really you can't just throw anything at it and see what sticks. You have to make the case in everybody for himself or herself, for that matter. So depending on your domain and your data, you might be well off with a traditional database,
Yep.
a traditional SQL database, or even less, even just a key value storage or something.
Yep.
Just when you have some structure in your data that is not necessarily trivial and potentially unbounded, like you said, the supply chain, you don't know in advance how many hops you're going to get in that supply chain, right? So you don't know when you have reached the end of that change. So this is as a rule of thumb, I would say, if whether your domain lends itself to a graph database or not, is try to explain your domain to somebody without any prior knowledge, right? Get your, I don't know, explain your domain to your parents or whatever, or to your non-technical friends, and get a pencil and a piece of paper and try to explain to them. If you're drawing a graph somewhere, and if a graph means circles and edges, arrows, circles and arrows, then chances are quite okay that your domain is suitable for a graph database. But yeah, you can't just put everything into it and say, "Oh, this is a graph database."
Sure. Well, look at the whole world is populated with examples of bad use cases for technology. Right? Yes. So all right. So you want to show us some stuff here?
Yeah, I can. So I'm gonna start fresh, and to not exclude anybody, I will open Visual Studio in a minute and go from there. Your IDE might vary, but to not exclude anybody, I will use a template, and I'm gonna create the template from the command line.
Mm-hmm.
So that everybody, even if you don't have the Visual Studio templates and stuff, you can at least recreate these things. And I'm going to .NET New Web API. And what this is going to do, so let me close this. I'm going to dive right into Visual Studio. This is going to create a very simple ASP.NET application. I think there's already some stuff that we don't really need, but all right, let me apply one screen. Let's wait for everything to turn up here. What we are really after is the one controller that's already in here, so we don't have to write that by ourselves. This is mainly for myself, because I wouldn't know how to write a controller from scratch. Like what's the base class, what's the attribute, I don't know. I will just usually always have to Google that. No chance. So I like the template. So yeah, and we're gonna go from here. So what this does, the standard controller, the example controller that's in here, it'll expose one endpoint, and this endpoint is gonna assemble randomly 5 weather forecasts for the next 5 days, I assume. Yeah, it's gonna assign some temperature to them and some summary. The summary is either one of, let me see, it's still loading. Yeah, already this is also very much appreciated. So, all right, the summary is one of those values. So in preparing this presentation, I thought, why not go from here? Because maybe people are already familiar with the weather forecast example, right? And I would just go from here. And since I explicitly don't want to convince anybody to use graph databases in general, I assume I will just, usually I would come up with a schema, a graph schema that is kind of complex, just to show off, right? What you can do with a graph. I will keep it very low, very low. We're going to extend this example to something that has this very simple schema. So this is our database in general. So
Okay.
there's cities, and there's forecasts, right? In the template, we have only forecasts. We will kind of extend that to cities and forecasts. So a city has a forecast. There's city vertices, vertices that have the label city, and there's forecast vertices with the label forecast. There's has edges. Has just I like I like assigning verbs to the edges and now nouns to the vertices. It has worked well for me, so I will do this as well. So we can read the graph like a story, right? A city has a forecast, and all right. So
Good.
we're gonna extend our entities first of all. There's a forecast, so I will introduce a common base class for all vertices. This is called vertex. And as everything in a graph database, it's got an ID, especially in Cosmos DB. The ID is a string. And also in Cosmos DB, every entity has got to have a partition key. So this is also of type string. I'm going to introduce this here. And this is our base class for any vertex, right? So let's have a base class for any edges. This is it already. We might add an ID property, we might add a partition key property, but since we're not setting those by ourselves, we can omit them.
You know, you did something smart there when you're with your model, in that you used you called the partition key. So
Yeah.
this is what I tell people when they're working on a new model. I said, if you don't know what you're going to partition by, just create a property called partition key, and then partition on that, and just assume whatever data you want to use for your partition key, just put it in that property, and then partition it, because the value there is you could actually change. You can actually change to something else if you wanted to, right? But just adding a new record and then using a new value that's a different property within that record, and then get rid of that one. So it actually allows you to do an in-place migration until you get a partition key you like, and then go ahead and name the thing if you want, because it's probably more intuitive that way. Or you can just change it in the POCO and map it to the JSON property itself. So anyway, just wanted to share that little gem with folks, because one of the things I frequently hear is I need to change my partition key and I have to migrate all my data out of my container. So,
and it turns out coming up with a good partition key is actually quite hard.
Right? It is.
I'm not sure in our development. I'm not sure if we got a, let's say, optimal partition key. It's got some properties that might make it a good partition key, but yeah, it's not easy.
It's partitioning is hard. It is hard. Yep.
So we're gonna have was just a single partition, and we're gonna preset this property to the string default. So we're gonna just assume one partition for the rest of this. So let's go on. So let's come up with our first actual entity. We have cities. So this derives from vertex, right? And every city's got a name. And that's about that. This is about as complex as this gets. So we're going to extend the weather forecast a bit. We're going to throw, well, we might actually leave it in, but we're going to throw this out. And I'm going to elaborate on that in a moment. So we have the weather forecast vertex. It's got a temperature property, the summary property, as we have seen. So what is missing is the has edge, right? So let's just introduce that. Derives from edge. And this is where I'm gonna put the date. And we're gonna see, later we're gonna see why I did that. Again, there might be different philosophies of where to put that. You might as well put it on the weather forecast as well, in the sense of this is no SQL, there is no normalization, this is no this is not SQL. We might actually have double data. We'll actually have redundancies, but for the sake of this, I'm going to go with this. So that's that. We got a base class vertex. This got an ID property, a partition key property. There's a city and there's a weather forecast. And we should actually let this derive from vertex as well, right?
Yep.
And there's an edge and there's an has edge. You might prefer doing this. I like reading code. Like eventually when you read code or write code in Gremlinq, you can almost read these things. You can almost go from city has weather forecast. It wouldn't sound that well when you would say city vertex has edge a weather forecast vertex, right?
That doesn't quite roll off the tongue.
So I like it like that. So next thing we're going to do, now that we have this set up, we're going to leave it all in this single file. Now we're going to the interesting parts. I'm going to add the Gremlinq NuGET. So I'm going to type ExRam.Gremlinq .providers, because this is the base namespace for all the provider packages. Cosmos DB, and there's actually two of them. There's Cosmos DB and Cosmos DB ASP.NET. So we're going to.
What's the difference?
So there's a core package, ExRam.Gremlinq core, which got all the logic, all the bits to serialize a query, to execute it, to deserialize the results. And there's the provider packages. Now you could easily set up all these things without ASP.NET, right? There's nothing, you could just as well write a console application. So there's no need to actually use ASP.NET. And you might go for the simpler package here. But there's also an ASP.NET package, which got all the boilerplate or plumbing for ASP.NET, so you can use it easily in your startup class and so on.
So does this provide support for doing DI for the clients here? Is that what that is?
Yeah.
Okay.
It does. Yes.
Okay.
So I'm gonna go for the latest preview, which is 9.0.0. There is a stable version 8.5 currently, which is perfectly fine to use, but I wanted to get some breaking changes in, and yeah.
Oh, you released this yesterday.
Yes, I did. Just
wow, that's fresh.
Just in time for this
fresh bits. Good.
Yeah.
Good.
All right, let's go.
You saw it here first, folks.
Definitely. All right. So now that this is installed, we're gonna go for our startup class. So
Yep.
this is the usual ASP startup class, right? This is
Yep.
configure
Create your
services
singleton object here, I'm
and
guessing.
all that stuff. And I'm going to go for the most simple configuration. There's tons of stuff you might configure that and do all kinds of stuff with that. The simplest way to use Gremlinq is to say add Gremlinq, and then you've got a setup class, and go for use Cosmos DB here. And again, the simplest overload for that is to give this method already your vertex base class and your edge base class and your partition key. So what you're doing is, since Gremlinq needs to have a model of your data, right? Because it's got all this inheritance support and stuff. So it needs to know your model. It needs to know your POCUS, your data. So it needs to create a model, and the easiest way to get this model into that is to use this overload, where you say, all right, go from there. This is my vertex base class. This is my edge base class. Look up all the inheriting classes and go from there. Build your own model. You can do all that manually and configure it to, I don't know, to no end. But this is really the simplest way. And it's got to know your partition key.
Yep.
Because it's going to exclude the partition key from updates.
Yep.
It'll only use the partition key to add new vertices, but never to update vertices, because you cannot update your partition key, right?
That's right.
So in case you would make the mistake of setting the partition key in your POCUS, that change would be ignored totally. So this is why it's got to know your partition key. And that's already that. Give it your vertex base class, your edge base class, and your partition key. And now you're set to use in your controller, or wherever you have dependency injection, you're set to use this interface, iGremlinq query source. This is usually denoted G. At least in Gremlin, everything starts with a G, which is for graph, when it's actually a traversal, but you usually go G dot blah blah blah, right?
Right.
So we're gonna call it G and store it in a read-only field. So let me see. The most simple operation that I'm about to write is getting a forecast. And I'm going to cheat a bit because the database is essentially empty. I'm going to cheat a bit again. The database is not empty. There's already a couple of cities in there. So I can start from there and use some of the cities that are actually already present. But I'm going to do this and say get a forecast, and the forecasts will not only get the forecast but create it. So this is just so we don't have to do any preloading of our database. So whenever you use get forecast, eventually it'll create a forecast, store it in the database, and return it to you, right?
Cool.
This is how we're going to go. So I'm gonna, as an argument, this should get the city, and the route should be the city. So you can go localhost weather forecast / Berlin for
Right.
that matter, example, right?
Yep.
So I'm going to start from G, and I'm going to look up the city. So I'm going to get all my vertices. This is what in Gremlin, what the V is for. and filter them on those whose name, no, sorry, I should say of type, right? Because the V is only going to get me objects. And now I'm going of type city. And I'm going to filter those on only those vertices whose name is city. Right? And now I'm going to add an arrow, an edge, if you will.
Mm-hmm.
I'm going to add a new has edge. And I'm going to assign it the current date. So this goes from that particular city to and now I'm going to add a new weather forecast. And I'm going to reuse all that stuff that we got here. I'm going to assign the temperature. All right, let me get the random number generator up here. And I'm going for this. So let me explain. We start out from the source, which is the source for every query in Gremlinq and in Gremlin for that matter.
Yep.
And we say, give me all the vertices. This is usually what the V does. And then we go of type city. Now this is where in Gremlin you would say has label. No, not has, yes, has label,
Mm-hmm.
right? Has label city. So you're going to filter all your vertices on only those that have the label city. And then you're going a bit further and say, give me only those that have the name property equal to city. And from there we go into, this is actually also a Gremlin operator, add E. We're going to add an edge that has the label has, assign the property, date, and we're going to point it to yet to be created vertex, which is the weather forecast vertex. We're going to assign some temperature to it and a summary. And about in Gremlinq, where in Gremlin, in pure Gremlin, you don't have such a thing as type safety, right?
Right.
At least not if you write a script, a pure Gremlin script. You don't know that there is no types in Gremlin.
Yeah, it's funny. This is a comment left on the YouTube. Basically, strongly typed graph access, right? Because you're right. It's no SQL, so it's schema agnostic or schemaless, if you will,
Yeah,
right?
definitely.
So yeah,
and
but this is
Gremlin,
providing that type safety, which is great.
yeah, I want to bring it back because I don't really like to have no type safety. I don't really like writing stuff in JavaScript or some untyped language, right? So I want that type safety.
Yep.
I want to know where I'm at. I want
Yep.
compiler support. I want
Yep.
to have the red squiggles when something's wrong. I don't want, as much as I can, have errors during compile time.
Yep.
So and this is very important to observe. It's all baked into those interfaces. I don't know if you can see that or if it's big enough for the audience.
Little tiny.
Yeah.
Seeing, is this the pop up the awaitable iVertex Gremlin query?
So what's
And
in
city type?
It's very important to observe the return types of all the operations in Gremlinq. So what this returns, the of type, is an iVertex Gremlin query of city. So it's got multiple information in here. The interface knows that it's a vertex query. So you got some totally different operations on a vertex query than on a, let's say, edge query, right? And it knows that it's of type city. And it's particularly useful to know that because it's got to know which type to deserialize in the end, right?
Right.
It's got to know that it's going to deserialize to weather forecast in the
Yep.
end. So on every step in Gremlinq, as good as it can, sometimes there's edge cases where you run into trouble and you have to do some nice tricks, but as much as you can, you have all the type information already here. You know that it's a vertex, you still know that it's a vertex, and now you're going for the add E. So now what this does is, since it knows that it adds an edge, and we're now on the edge, like the moment you say add E in Gremlin, you're standing on the edge. Your little Gremlin is no longer on the source vertex, but rather on the edge. It knows that this is an edge query. Actually, it doesn't really know yet whether it's in or out. So it says I in or out edge Gremlin query. But it knows that the edge is of type has. And one of the adjacent vertices is of type city. Now the moment you go to, it's got all the information it needs. It returns to you an I, both edge query, Gremlin query, and it knows the has edge, the city, and the weather forecast.
Yep.
So now the moment, now you're still on that edge, right? Your little Gremlin is still standing on that edge. And it could either go back to the source or go ahead to the target. When you say in V, that means go to the in vertex, the vertex that the newly created edge goes into. And this is going to get you an I vertex, the Gremlin query of weather forecast. So the whole type system has you covered. You create those vertices, you look up the city vertex, you create an edge, you add it to, you let it point to a newly created vertex, and the type system is smart enough to know where it's at. So now we got this. This is exactly what we want. And this is just a query, right? There has nothing happened yet. So if you're ready to execute it, you might do, in general, you might just do to-array async, right? It's going to get you an array of all the results, even if there aren't any. Since you know that we're going to have one single vertex only, if at all, but we're going to assume that there is exactly one vertex, we're going to go for first async. And this is going to get you a value task of weather forecast, right?
Mm-hmm.
And we're going to return that. Going to make this async and just return this newly created weather forecast. Now let's, yeah, we might already execute that. Any questions so far?
So that nothing from the viewers. So this basically is already cast, is what you're saying, because you've got it defined within the vertex add v there, right? So there's no need to angle bracket cast this thing into anything off the first async, right? It's already there, right?
Do you mean by angle bracket cast?
This is already strongly typed, is what I'm saying. Is that the output of first async here? It's already typed as a weather forecast, right?
Yes.
Yeah.
You mean this?
Yeah. Well, the return value that you've defined here in your Gremlin query.
Yeah.
Yep. Yep. Okay.
This already knows that it's going to return.
That it's a weather forecast. Yep.
Yeah.
Cool.
This is what you want to have, at least in my book. I wanted to have this. I wanted to know where I'm at. I wanted to know the types. Yeah, get me as much information at compile time as
as you can get, right?
Possibly,
Just like any C# or .NET developer would want, right?
yeah.
Just give me that type safety. Right. Yeah. This is great. I love this thing.
So we might just run it in a
Give it a
browser.
try. Yeah.
What are we gonna call? It's just weather forecast and then the city, right? No, I forgot some very important thing. Very important, and this is due to the excitement. I'm sorry. You got to tell Cosmos DB where to connect to, right? What to use.
Yes, your connection string back in your.
This is pretty much nowhere.
Okay.
You might as well do this around here, but since this is already so baked into ASP.NET, we're gonna go for configuration in our app settings. And we go on top level, we go Gremlinq. And then for every provider, there is a separate section. We're gonna go for Cosmos DB here. Let me see, yeah, should be fine. And give it the URI. This is usually something that would start with WSS for secure WebSockets, right? Then it's got something like EuroCount at .gremlin.cosmos and so on. I'm not going to enter this here because it's already in my environment variable. And this is just by magic, by default, put into your ASP.NET application, right?
Yep.
So it gets the app settings JSON and some other app settings JSON and the console, the command line arguments, and also the environment variable. So to not, because this might already be considered sensitive information, right? It's not in my case, but just to show off that you can actually have this information in your environment variable. I'm just gonna leave this out. And next thing I'm gonna have to tell Cosmos DB is which database to use, because there's databases and containers. And
Well, or graphs for you guys.
Graphs, yeah, right. This is conveniently called graphs, and the graph is called Cosmos DB TV. So this I created yesterday just for the sake of this. And of course, there's going to be a password, which is called the auth key in Cosmos DB. So I'm not going to disclose this either because it's as well already in my environment variables.
Mm-hmm.
So I might actually set these here because they're going to be overridden after all, right? But I'm going to comment these out. Fortunately, comments are legal in this JSON. And that's that. You have a Gremlinq section, a Cosmos DB section. Give it the URI if you want to get the simplest way of doing that. The database, the graph, and the auth key. And now it should know if I didn't
Let's see
any more stuff than it already did. It should work from here.
Okay.
So
live coding. This is always exciting.
Building. All right, and it's got already Swagger set up in the template. And I'm gonna go for, let's go for my hometown, right? So we're gonna go the local hosts on this particular port /weather forecast /Aachen. Let's see. And here we are. So let's just step through it. There's actually not a lot to step through.
Yeah, it's just one long line. or one giant gremlin step.
There you go. So what it actually did is there's this weather forecast entity returning from your execution, from your query. We might actually debug that a bit in a moment. But what ASP.NET does, it takes that POCO and serializes it to JSON, right? So this is not actually what you're getting from the Cosmos DB server, but this is just the weather forecast serialized to JSON again by ASP. Right? So it's got a temperature and a summary. It's cool. It's got an ID. We didn't set that. Cosmos DB did that for us. And it's got the partition key. It did set that. We did set that.
Yep.
So let's, for the sake of clarification, introduce an intermediate variable. And we start. Just to show that the POCO is really there. Takes a second. So let's have a look. Now this is my POCO, right? This is my weather forecast instance. It's got the ID, it's got the partition key, it's got the summary, and
I don't know if I agree with the summary and the temperature.
yeah,
they seem a bit at odds with each other.
Definitely.
I don't know. You could be from Finland, I suppose, and that would feel warm to you, maybe. So,
yeah. I'm wondering whether it already returns the 0 temperature C. It shouldn't. Maybe it's just a coincidence that it was 0. We're going to get to that. So that's that. This is the most simple thing to do here.
Very, very cool, I got to say. I've only dabbled in graphs and done it kind of the old school way with basically untyped using the Gremlin.NET client. And, this is very cool. I think now I want to go back to some of my Gremlin samples and projects and redo them using Gremlinq here, because I want what you're saying and what the value prop is for this tool, which is you get kind of that strongly typed kind of environment, the type safety, the compile time check. It's kind of the same stuff that I want when I'm doing regular Cosmos, when I'm just working with regular POCOs and serializing and deserializing stuff in and out of those things. I want stuff like that. I don't like working with just straight up dynamic types all the time, or just vars or whatever within there. So I like having that, auto completion or type safety or compile time checking, which is what you're getting out of this here. So it's very cool. Really well done. How long is this project? How long have you had this project out?
We started working on that like 4 years ago, I guess, when we were still evaluating graph databases, and yeah, we started from there. But it hasn't been mature for, I don't know, at least until, let's say, a year ago or two. Let's say 2 years. Only then has it become really that mature, and we are using it in development, and yeah,
that's great. That's great. You get a lot of feedback from the community on this, or are they filing lots of issues on your repo? I guess.
Yeah. It kind of piles up, or should rather say, it's increasing. I get increasing feedback. kind of getting some momentum, I guess. But I could definitely, from the issues I get, and I can definitely say people are generally new to that. Like the feedback I mostly get is, thanks a lot, I wouldn't have considered Gremlin on .NET without this, especially not on Cosmos DB, where you cannot write fluent queries yet because there's no bytecode support.
Yeah.
Because I should say the Gremlin.NET library, which lies underneath this and does all the serialization stuff for me. You could write fluent queries, although not typed queries. So you could write something fluent like .v, let's see, and then add v, and then a string like city. Right?
Yeah.
And then has label or something. But you will always have to use strings, and you don't want to. The nice thing about that, it refactors easily. You rename stuff, you rename everything, right?
Yep.
You can't, don't do that with pure strings.
Yeah, right.
ReSharper can offer you to do that to your strings, but yeah.
Yeah.
Yeah, it's kind of getting some momentum on GitHub. The issues I usually get are mostly concerned with the signatures and how to use this properly and how to translate your Gremlin into Gremlinq. And a mistake that people often made is you should have some familiarity and some prior knowledge with Gremlin before you start writing queries in Gremlinq. You should roughly have an idea of how the Gremlin should look like.
Okay,
right?
so
What
you got new users asking you, how do I do Gremlin, basically, when they should just go to TinkerPop site.
Yeah, right.
Yeah.
And also how to use this particular overload or things that don't compile, and yeah. And as much as I would like to answer all these things, time's limited, right?
Sure.
So as always in open source, there's one maintainer.
That's you.
Yeah,
mostly, I guess. I don't know. Do you have others on your team that are contributing into this, or is this primarily run?
I'm afraid no.
Yeah. Okay.
So yeah, but usually I can learn something from the issues. Like if there's something that's not entirely clear, or when there's a bug, yeah, there's always opportunities to improve. And as much as I would like to, the most asked question on anywhere is, are you going to provide some documentation for that? Or do you plan to provide some documentation for that? And sure, I do plan to provide some documentation for that. Just hasn't materialized yet.
Yeah.
Because writing this is fun, right? And writing documentation, not so much.
As a program manager, I can attest to that as well. So some docs are fine. I don't know. I like doing some things, like writing samples can be fun. It depends, I think, on kind of what it is you're doing. Docs themselves, no, but it's a necessary evil, right? Because it hopefully helps reduce the number of questions you get from users as they're learning your whatever it is you're building, your library, your API, your service, whatever. So
Speaking of samples, there is when you go to that GitHub.
I'll put that back up.
There is a link to a samples repo, which is just this URL with .samples, and there's some nice example code to be copy and pasted. There's a console application, and there is an ASP.NET application to go from. Just very simple, very rudimentary.
There, we'll change that. Is this it?
Yeah, perfect.
Okay.
Perfect.
Make it easy for people.
We could go from here if time permits. We could do some more advanced stuff.
Yeah, you want to show us another sample here, or?
Yeah, I could. I'm not going to do the most advanced stuff. Leave this for another day. But yeah, to dabble a bit with the methods and the signatures and show what can be done. For example, a lot of the power of Gremlinq is to it's able to translate your C# expressions, in that case just x.name equals city, into valid Gremlin code. So you might as well just write starts with A, right? And let's see what this does actually. Let's execute this. And throw from here, just for the sake of this. So what Gremlinq does, it's able to realize your intention when you write xname starts with A. Oopsie. And translate this into valid Gremlinq. So let's see. And observe that the city argument is going to be completely ignored, right? I'm not going to use this anywhere. And don't be set back by the time it takes. This is just usually the JIT compiler. Right?
Mm-hmm.
Subsequent queries are going to go much faster than that. So let's see. This is a city, and it's called Aachen. So it has successfully found the city whose name starts with A. We can actually debug the query. We can actually, and this is a hint for everybody who would like to see what this actually translates to. Just write debug. It's not async, so no need to await this. And let's see what we get here. Let's have a look. The debugged query, I don't know, is this large enough for everybody to see?
Yeah, it's pretty small, but I can kind of make that out.
So the Gremlin query that this would translate to is the G dot is omitted, but the V has labeled city, has put the property name, and then starting with the letter A. And this is valid Gremlin, right? If you add the G dot, if you prefix it with G dot, this is valid Gremlin. You might just as well execute this from your Cosmos DB data.
Yeah, you could do it right from the right from the portal.
Right. And actually, Gremlinq is capable of recognizing and translating a whole range of expressions. You might do this. Xname starts or ends with lowercase n. Should be the same, right? For Aachen. Or you might go for this. Then you get Berlin. So it can recognize all these expressions, and it can even do some math. If you got an int property, you can do some math. We're gonna get to this in a minute.
So do you have do you basically support everything within the Gremlin language there, like all of its features?
You mean expression-wise, or or do you mean the Gremlin operators?
Yeah, well, both, I guess.
So for the expressions, I think I got it covered quite extensively. I'm not I don't know of any expression that I'm not aware of any valid Gremlin syntax that you could not come up with in an expression here in
Got it.
Gremlinq. So whenever you could write has name, comma, whatever, I'm not aware of anything you could write that you could write in Gremlin that you could not write in Gremlinq.
Got it.
If there is something, I'm pretty sure there is something, right? There's probably a whole range of stuff, a whole range of predicates, text predicates or whatever. If there is something, if you feel that this particular piece of Gremlin should be supported in Gremlinq, it's always good to open an issue and give me a
Kind of a use case for it.
A use case, not necessarily a use case, but some code I can execute. I specifically ask for a minimal repro.
Yep.
That I can just clone and run, right?
Makes sense.
And see what's going on.
Yep.
So if you feel that there's some valid Gremlin and there is some corresponding valid Gremlinq which doesn't compile or which doesn't execute, yeah, I'm always happy to get these.
Okay. No, I was just more curious. Like, did you go through the whole spec and as you were implementing this, or was it?
No, definitely no.
Okay.
There's a couple of operators that are nowhere to be found. For example, there's a subgraph operator in Gremlin. There is no subgraph in Gremlinq.
Got it.
Usually the answer to why is this not implemented is because I didn't need it.
That's a good reason.
Because this just reflects what we needed, right?
Sure.
For our daily work.
Well, do you take pull requests?
Yes, of course.
Well, there you go. So someone could file an issue, and then you could say, "Look, if you really need this, just submit a PR, and we'll take a look at it." Right? So
definitely.
Maybe this show will get you some contributors who want to help out and submit a PR.
Yeah, definitely welcome. Make sure to add a test. Make sure to add some test coverage to your new code. That would be nice. But yeah, I believe, but yeah, that's what every developer says, right? I want to believe that the Gremlinq code base is quite straightforward, or at least it's kind of clean. So everything is immutable in Gremlinq. There is no mutable state nowhere. So that makes it rather easy to reason about code. So you don't have to understand any cross dependencies between things and timing issues, and you can have a pretty local view on where you currently are in your code. And this makes extending Gremlinq pretty easy, at least for me. An extension is usually pretty local to some files or some classes. No need to understand the whole code base. I would say just clone and dive right in. Everybody's welcome to. Yeah.
Well, cool. Well, this is great, Daniel. Really appreciate you coming on and showing us Gremlinq. This is really, I'm glad I had you on. This was great. I'm definitely going to download this. And like I said, redo some of the Gremlin samples and stuff I wrote and do it on this thing, because I think this is very, very cool. So
thanks a lot.
So let me show you, everybody. Here's repo if you want to go and check out the source for this thing. Just check out the README. There's samples hanging off this thing as well. Just this URL.samples. Quite a bit of stuff in here to go check out, and go download from NuGET today and play with it, and go create a new Cosmos Gremlin API account and play with it. Right.
Yeah.
So we got our freaks here.
Ideally.
Right. And it works with the emulator too, right? So our Windows
It does.
emulator,
Yeah,
right? So you don't
it
even,
does.
you just use that locally on your machine, and
Definitely.
so
And actually, this is how we do integration tests. So we
yeah.
got a whole test range. We do some integration tests for Gremlin server, which is the reference server from TinkerPop,
Yep.
Janus Graph, and also Cosmos DB on the
Cool.
emulator. Works well.
Cool. Well, right on. Well, thank you so much, Daniel. It's great having you on the show.
Thanks for having me.
Thanks everyone for joining us. Next week, episode 10, we're going to take a look at our new Linux emulator. I know a lot of people are been waiting for this and excited to hear about it. If you follow me on Twitter, I might have let slip that we are working on one. So next week, we're going to take a look at it, and Stephanie Arroyo on our team is going to show you how to acquire it, configure it, use it, all that good stuff. So join us next week here. Daniel, thank you once again. Great having you on the show.
Thanks for having me. Thank you.
Okay, thanks everyone. We'll see you next week. Where's my thing? There we go. All right. Bye-bye, everyone.
Bye-bye.